novel project in that it has, tremendous potential to treat neurologic disease in humans, but it also has the potential of really expanding the sheep industry in the United States as we know it.
I'm Susan Holler, and this is Larry Holler, and we live in White, South Dakota, and our business is Glycoscience Research, and we are also members of Dakota Lamb Growers Co-op. We're going to talk today about the Glycoscience Research and the GM1 ganglioside project.
The GM1 ganglioside project in its infancy started over 20 years ago. The molecule GM1 ganglioside was developed as a treatment for a variety of neurologic diseases by an Italian pharmaceutical company. And they produced their GM1 ganglioside from cow brain tissue. Unfortunately, with the advent of mad cow disease in the early 90s, all of their research basically went down at the hands of mad cow disease. At that time, I was working on a genetic animal model of a disease called GM1 gangliosidosis. And the hallmark of this genetic disease is that the animals accumulate massive quantities of GM1 ganglioside due to a deficiency of a single enzyme. I was working at Washington State University as a pathology resident and a PhD graduate student. The program I worked in actually specialized in animal models. We did animal models of a number of human diseases. And GM1 gangliosidosis actually occurs in humans, and that's why we were initially interested in these sheep, looking at the sheep disease as a model for the human disease. And as we went farther on into our research, we realized just how much GM1 ganglioside these animals produced. It's an astronomical amount of the chemical over their lifetime that's accumulated. At the same time, the Italians' research was actually going downhill. They could note the FDA pretty well banned them from using unknown bovine raw material. This is a kind of a transition from my life at Washington State to South Dakota State. We sort of realized that maybe these sheep would represent an opportunity to replace the bovine material. The university sold the research flock of sheep and we purchased them, and we've been working essentially ever since developing and trying to perfect this source material for GM1 ganglioside production. The reality is this project, if successful, will require potentially hundreds of thousands of new sheep in the United States.
This ganglioside research is here and now. We have decades of data, hundreds of papers on GM1 ganglioside and what it can do for neurologic disease. We have Dr. Stephen Hirsch at Massachusetts General Hospital, Harvard Medical School, and he is a world-renowned Huntington's disease researcher, and he's a strong supporter and believer in this project.
The FDA requires that all raw materials from natural sources be source verified, and basically that means they want to know everything about that animal that produces those molecules. And that's what's unique about this, is every one of these animals is identified at birth. Records are maintained. We have essentially 20 generations worth of records and data. And going forward, that's what the FDA is going to want to see. Adding cooperators, that tracing and tracking becomes a little bit more of a challenge, but sheep producers are adaptable. They can keep records, they can do identification. There's nothing about raising these sheep that is inherently difficult, inherently different from what good producers do every day in their own production system. And I think that's what's critical for the success of this project, is that this is just good quality sheep production, represents a tremendous value added agriculture bonus to the producer. There's definitely more money in producing pharmaceuticals than there is lamb and wool. While we still have lamb and wool as byproducts in this project, you know, the reality is that each one of these lambs hopefully can treat a Huntington's disease patient for a year, and that makes that individual animal fairly valuable.
This is a barn where we have the lactating ewes. These ewes all lambed in May. These are our 1 and 2 year old ewes, so they're young mothers, and we're about ready to wean these lambs, so they've been lactating for a little over 2 months. The mothers are all identified. If you look at the ear tags, if they have a C on their ear tag, they are a carrier animal, and the lambs have been sampled, and the genetic test results are pending. We wean them when the lambs are about between 60 and 90 days of age, and then it's an extra nutritional stress on the ewe to be lactating. So they get to a certain age and we wean the ewes so they can recover and be ready to breed again in the fall. And then the lambs are old enough, they should be on solid feed, and the lambs will stay up in the barns so we can keep close track of them, and the ewes will go out on pasture. This is an interesting place because we are so low and wet, and the nutritional value on pasture is really not enough to grow a lamb. It can sustain a non-lactating ewe pretty well, but there's all sorts of different nutritional requirements, and for growth and good healthy gains, unfortunately our pasture is too wet. There's not enough nutritional value in it. These are ewe lambs, so they're females, potential breeding stock. They're 3 to 4 months old. They won't go out to pasture until after they've lambed and been weaned. That first year of their life, they stay up in the lots, so we can monitor their growth and keep track of them. And then once they've lambed and weaned their lambs, then they can go to pasture. So we've already sorted, and these are normal and carrier females. Visually, we can look at these lambs, and if they're not showing any signs yet, we assume they're a carrier or normal. If they're showing some uncoordination issues, then we'll pull them. We also do a genetic DNA test to verify their genetic status. So they're either a normal lamb, a carrier, which appears to be normal, or an affected lamb, which are the ones that are a rich source of GM1 ganglioside. The average person, and even other sheep producers, wouldn't be able to tell these are affected. I can pretty much tell. As they come out, I can see some movement things, because these guys are 3 to 4 months old now, and we harvest 4 to 6 months of age. So their GM1 ganglioside has built up quite a bit. Well, I can notice in these lambs some gait issues. It's to be honest, it's very subtle. Like that one walking there, his front legs move a little different. I've had some people notice that they're maybe not as lively as some other lambs. And as the GM1 ganglioside accumulates more, their growth slows down. They kind of start to fall behind their peers. These are anything that's not an affected lamb. So most of these we've sorted by sex. So these are all the males. You're either a ram lamb or a wether. So the males are in this barn, the other barn was the females. And then we grow these out, and these are intended for market, and they'll end up on somebody's dinner plate down the road. We start marketing by the time they're about 5 months of age. So we're harvesting the affected lambs between 4 and 6 months of age. These guys reach market weight, about 130 pounds, usually about 5 to 6 months of age. So they basically have about the same lifespan. These sheep here, if they have a C on their tag, they're a carrier ewe. That we've identified them by the genetic test. These two right here are not. They're normals. So you can see they look like any other sheep. If they didn't have a C on their tag, you wouldn't know they were any different from anybody else. And you also can see that we've done a lot of crossbreeding. So people always ask that as a specific breed. And other than that, we did find this trait initially in Suffolks. You can crossbreed it into any sheep that you want. These are mostly carrier rams. This one back here on the right, he's a purebred registered polypay, actually from Jim Hansen. So every once in a while I bring in an outcross ram to keep some outcross genetics, and he's had some nice lambs this year. The rest of these guys, you can see this is an Ile-de-France cross. That's a carrier RR ram. This is a Suffolk carrier RR. That's actually a older, he's got some Rideau-Arcot genetics in him from Greg Taylor. He's an older carrier RR ram. So these rams were all born a year ago spring. Basically what we do, we start even in the lambing barn selecting them. So initially you have to be structurally sound, straight on your legs. You know, we come across a ram that's a twin or better. So these guys, I think they're all twins or triplets. We do have quads every once in a while, but you know, we'll save them if they're a carrier. But so they're no parrot mouth, no inverted eyelids, and then we grow them out. So we wait for our carrier test results to come back, and we take weights on them. These guys were a good set of white-faced rams. They all gained over 9/10 of a pound average daily gain to about 120 days of age. We do evaluate testicles. That's the working part of a ram. So we'll palpate testicles, make sure they have two, make sure that they palpate normally. And then if they pass all those criteria, we will go ahead and test them for their scrapie codon status. So all these rams are all RR based on their scrapie test, and that is RR at codon 171. For our farm, that's how we select these guys. So for a cooperator, if they're going to sell rams, which is another value-added component to this project, if they're going to sell breeding animals, they have to be a carrier and they have to be an RR. This room is currently our harvesting facility, and it's just an on-farm facility. Eventually we'll need to harvest all the animals in a inspected, probably a federally inspected plant, but this is what we're using right now. So it's very humane. The lambs are in that pen and they come into this, you know, just a few feet away. The meat is, you know, is usable for us. We currently can't sell it. And then we collect the tissues, and the tissues go into the freezer. Basically we have about a gallon Ziploc bag on each lamb of tissues that'll be a rich source for GM1 ganglioside. Individual animal identification is extremely important, not only so you know what the genetic status of the animal is, but that is absolutely what FDA will require. They want a source verified product. So once we get the GM1 ganglioside in a vial ready to treat patients, we need to be able to trace it all the way back to the individual animal it came from. So those animals, whether they're electronically identified or a visual tag, pretty much always we double tag animals because sometimes you lose tags. So you have to be able to trace all the way back to that animal. So when we harvest the tissues, you need to be able to trace back to the animal that it came from, and when it goes the other way and gets purified into a vial to treat patients, that whole system needs to be traceable. So you want to be able to identify not only the affecteds, but your carrier animals, because those are your potential breeding animals. So our cooperators, they need to do the genetic testing so they can identify which lambs are normals, carriers, and affecteds. The current agreement, they're supposed to return the affected lambs to us by 90 days of age, which is when they may not even really be showing signs at that point. We just looked at some lambs that are probably 90 to 120 days, and it's pretty subtle. So our intent is to have those lambs back here in a nice, safe environment where we can continue to grow them, and then we'll watch them and we'll know exactly when they're ready for harvest. So to start out, first you have to sign the agreement and agree to the terms, and then people have been picking up a carrier ram. So if you already have your own ewes, you can breed that carrier ram to your own normal ewes, and the first generation lamb crop, 50% will be carriers and 50% will be normal. And then when you come back the second generation, you can breed carriers to carriers. Well, you'll get 25% normal, 50% carriers, and then 25% of these affected. So if you're starting with your own normal sheep, it actually takes you 2 generations to start producing these affected lambs. And so getting into the pharmaceutical market, that's always been a concern, because once we get through clinical trials and they want to start using GM1 ganglioside, if we don't have the production at least ramped up to the carrier stage, it would take us 2 years to breed these affected lambs. And that's always been kind of the balancing act with this project, is how do you keep the sheep production in sync with the need for the pharmaceutical production. So it gets into clinical trials, and we already are almost certain what the results are going to be. There's enough data out there. It's going to be very promising, and people are going to want to start using GM1 ganglioside, and it'd be very hard to say, oh, sorry, but you have to wait 2 years.
I think this project has tremendous potential on two fronts. One is the obvious hope for a treatment for a devastating disease, which is Huntington's disease. The reality is it's also a tremendous agriculture value-added project. If we are successful in developing a treatment for neurologic disease, the demand for these special lambs will be tremendous. Even at 1 lamb per patient per year, hundreds of thousands of lambs will eventually be needed, especially if the application goes forward into Parkinson's disease or hopefully someday Alzheimer's. We think it has tremendous hope and potential. We know just from the enthusiasm from the sheep producers already involved, the enthusiasm of the sheep producers who want to be involved, that coming together the sheep industry can solve this problem. It deserves its chance. We can't give up until we get to clinical trials and let GM1 ganglioside, let the sheep source have its day. It is about people. This isn't about money. It's about people helping other people. And
we haven't given up because we know the potential that it has, and we've gotten to really care about these families, and we can't give up.